Okay, hi, I'm Ashley Bunker. I'm in Physical Science 100, and my professor is Professor Bierman. I'm gonna talk a little bit about the buoyancy force in this demonstration. So, I will now demonstrate what happens when I stick two bottles that are the same size and shape into the water. Which one will have a greater buoyancy force acting upon it? Because they have the same surface area. The only difference is that this bottle is heavier than this one. It's because this one has a lot of grams of sugar in it, and this one doesn't have any because it's healthy for you. It's Diet Coke. So now I will stick them in the water, and we're gonna see what happens. Zoom in on this. Look! The Coke is sinking, while the Diet Coke, I don't want them to go away from me, is floating on top of the water. Hey, zoom in on that Coke bottle that just went to the bottom of the pool. See, they're the same size and shape, but the Coke bottle sunk because it has a lot of sugar in it. It's amazing. So, in conclusion, the buoyancy force is the same on both of these two bottles. They've got the same buoyancy force pushing up on it. But the Coca-Cola sunk because it's heavier, and the Diet Coke is lighter because it's diet. And it's less weight, that's why, because it's less weight. So that's amazing, right? Great, now I will show a different principle. I now have these two bottles which have the same weight. So they will have the same downward force pushing on the two bottles. However, this one's really big because it's a 20 fluid ounce bottle, and this one is only 8.5 fluid ounces. But I emptied it out so it has the same weight. They both weigh 292 grams. So I will put them in the water and see what happens. Well, as usual, the Coke bottle sunk, but this one has not sunk. It's just floating on the water. And why? Is because this one is displacing more water than that one is. So the volume is greater. So the buoyancy force on this one, it has a greater buoyancy force. So if we remember back with the Diet Coke and the Coke, they both have the same volume, so they're displacing the same amount of water. They're displacing the same amount of water, so the buoyancy force is the same. But the downward force on it is different because they're different weights. These two Cokes have the same weight, so the downward force is the same. But the buoyancy force going up is different because this one's displacing more water, so it has a greater buoyancy force. And that's my project, folks. Tune in next time.